Okay, we're in section 12. That's the polynomial factoring. And this is a continuation of what we've done before. What we've done before is the greatest common factor, factoring by grouping, and then the quadratics, ax squared plus bx plus c. This is going to be a section on special factoring, and we covered that section already. I put two things in boxes for you, and I want to point out for most students, although I believe these you could get these by trial and error, most students can't. So we recommend you memorize these formulas over here. The formulas to memorize are going to be the difference of perfect cubes, that's a cubed minus b cubed, and the sum of perfect cubes, a cubed plus b cubed. If you're looking at textbooks, though, they mention that there are quite a few special ones. For example, they mention the difference of perfect squares. Again, most students can do this by trial and error. They don't need to know or memorize that formula. Perfect squares type 1 and type 2, and that is a minus b squared, a plus b squared. All right. Relatively simple. Again, most students do not need to memorize that. What do they need to memorize, though? Let me point this out. The two that are in boxes, the difference of perfect cubes and the sum of perfect cubes. So then what do? We went through a bunch of examples. The examples we went through, some were done by trial and error, some were done because they were special. And what I mean by special, you have to memorize those. All right. So we did those examples in class. And then, of course, the expectation is you study the material, try to make sense out of the material that's being presented to you, and then try on your own. And that's what homework's about. I'm going to switch over to the whiteboard, and we'll start doing homework now. Again, the expectation is that you've done the homework and that you're just watching this to reaffirm that what you're doing is correct. All right. So like self-assessment. Just give me 1 second. I got to launch that whiteboard for you. Okay, you're seeing the whiteboard. You no longer see the notes. The notes should be in your hands, though, as should the homework, and it's certainly done in a separate notebook somewhere. We're in section 12, and we're doing the homework now. So number 1, what does it say factor? I'll write this down for you. 8y cubed plus 27. Well, again, my claim for this one over here is most students will not be able to do this by trial and error. However, you can try. It does work, right? My claim over here is these are the forms you need to memorize. And write down the two forms you need to memorize. A cubed minus b cubed, that's 1. That would be a minus b times a squared plus ab plus b squared. The other one you need to memorize is a cubed plus b cubed. This is a plus b. They're remarkably the same, by the way. All right, point this out. This is a difference of perfect cubes. This is the sum of perfect cubes. These are the formulas that we went through in class. These are the two that we say you need to memorize. All right, let's write this down. And I'm looking at it, I'm wondering which one of those two is it. So I'm looking at it. I'll write this over here very carefully. 8y cubed plus 27 is actually a sum of perfect cubes. Where the perfect cube's going to be? Well, the first one's going to be 2y. And why is that? 2y cubed is 8y cubed. What cube gives you 27? 3. So when I'm looking at this one over here, I want to claim what we're looking at is this thing here. All right, we're looking at the a plus b thing. Let's write that down. I want to claim to you, look at this over here. The a is 2y, and the b is 3. Let's write this down now. What do you see? A plus b, which is 2y plus b, which is 3, times a trinomial. Now, what's a trinomial going to be? Well, a squared. So if a is 2y, a squared would be 4y squared minus the product of a and b. What's 2y times 3, which is 6y, plus the b squared. What's the b squared? 9. What we'd like you to do is look at the answer key and see if you're seeing that. And you are. You're seeing 2y plus 3, 4y squared, minus 6y plus 9. You can also check these by multiplying them out, right? That's a special pattern, right? Which one do we use? This one here. It was the sum of perfect cubes. All right, let's go to number 2. And what do you see there? 12t cubed minus 75t. Now, unfortunately for a lot of students, they see this thing and they say, oh, it must be the cube. It could be. I'm not saying it's not. What I'm saying is you need to go through your list of things first. And the first thing on your list is there a GCF? And there is. And what's the GCF going to be? I'll write this down for you. 3 is a common factor between 12 and 75. And t is a common factor between between t cubed and t. So what are you left off with? 4t squared minus 25. Now my claim over here is that, you're looking at it, and I certainly have a 3t, but then I notice there's a quadratic over there. And my suspicion is it's going to be doable. Let's give it a try. I'm going to say 2t and 2t and 5 and 5. If you want to know the name of this, you want to consider it special, it's a difference between perfect squares. But the bottom line is I can still do this by trial and error. It's quadratic. Generally speaking, it's pretty easy to do. Let's just check it. 2t times 2t is 4t squared. That worked beautifully. At the end, what do we get? Minus 25. That worked beautifully. My real concern is, do we get nothing in the middle? And we do, because we'd have 2t times minus 5 is minus 10t. And then we have 5 times 2t, which is 10t. Minus 10t plus 10t is no t's. And that's good. I want to recommend you still look at the answer key. Make sure you're staring at the same answers we're saying you should be staring at, which is 3t, 2t plus 5, 2t minus 5. Let's go to number 3. And number 3 is 9w squared minus 16. And again, if you want to know the name of this, is a difference of perfect squares. But my belief is it's quadratic. We're going to be able to do this with trial and error. So 3w, 4 and 4. This is a try. Plus minus is a try. Let's see if it works. 3w times 3w is 9w squared. Then you get minus 12w plus 12w. The w's disappeared, and we do get minus 16. What do we recommend? Look at the answer key to make sure you're staring at that factorization. All right, let's go to number 4. And number 4 is 8x cubed plus 27. I want to tell you something about this one over here. This looks exactly the same as number 1. The only difference is there are x's and you only had y's in it. So here's the deal. When you get to when you get to the next exam, you're going to see problems that are almost exactly the same, but they change letters around. So what I want to do is write down, I'm hoping this is this pattern over here. But I can't say this enough times. This is going to work as advertised. Let's write this down. What's going to be 2x cubed, that's what 8x cubed is, by the way, plus 3 cubed. What's the a? 2x. What's the b? 3. What's the a? 2x. What is it squared? 4x squared minus 2x times 3, that's the a times b, which would be 6x plus the b squared. Well, it's 3 squared, which is 9. Again, when you take exams here, the questions will almost be identical. They might change a letter, right? It really isn't much changes in what we're doing. Let's take a look at the answer key, though. There's always a chance I made a mistake, but I see 2x plus 3, 4x squared minus 6x plus 9. Again, that question was almost identical to question number 1. Let's go to number 5. And what do I see over there? Well, I see 2z cubed minus 8z squared y plus 8zy squared. Again, some students look and say, oh, it must be one of those cube patterns. I'm not saying it's not. All I'm saying is I'm looking for the simplest thing to do first, which is going to be the GCF. Well, 2 is a common factor between all 3 terms, and z is a common factor between all three terms. Z squared minus 4zy plus, let's see what you get there, 4y squared. Now here's the deal. It's going to be workable. All right, what do I mean by that? Trial and error. It's quadratic. It's got to be z times z because z times z is z squared. If this is the work, that's the only choice. Now the 4y squared on the end, it could be 4y and 1y or 2y and 2y. I'm going to go with 2y, 2y. Minus, minus. I want to point out this does work because z times z is z squared. Then you get minus 2zy minus 2zy, which is minus 4zy. And of course, minus 2y times minus 2y is 4y squared. So this is correct. I'll put a box on it. There's another way to write this down. 2z minus 2y squared. Right? Go to your key and see if that listed as an answer. And what am I saying? 2z minus 2y, z minus 2y. 2z, 2 factors of z minus 2y. All right, let's go to number 6. Again, if this is going too quickly for you, you probably haven't studied or done the homework. If you've done the homework, it's just a verification of what you've done is correct. All right, so number 6, again, it might seem more difficult to you, but it should be a reasonable problem to attempt. So what do you see in number 6? X squared minus y squared, and you see x cubed minus y cubed. Again, the x squared minus y squared is a difference of perfect squares. You don't need to know the formula. And by trial and error, it's really not that bad. What do you see? X minus y, x plus y. I want to point out what we're doing. We're just doing this guy right over here. What does that give me? X squared minus xy plus xy. They disappear. Then you get minus y squared. Now, I want to be honest with you. For a lot of students, this is more difficult. But what I know is it's a difference of perfect cubes. Let me write this on the side for you. A cubed minus b cubed is going to be a minus b, a squared plus ab plus b squared. So what am I saying? X cubed minus y cubed. So the a is x, the b is y. So what do I get? X minus y, x squared plus xy plus b squared. Well, b is y in this case, so y squared. So I'm ready to write that down. X minus y times x squared plus xy plus y squared. Now, I know a lot of students are going to be looking at this guy over here and wondering, it's quadratic. I'm wondering if you could factor it. Yes, it's factorable, but not using finger numbers. So we're not going to go anywhere near that. What we're going to do instead is we're going to do this and put it in a box and call it a day. However, I want to point out this can be written a different way. It can be written as x plus y. I see 2 factors of x minus y, and then I see 1 factor of x squared plus xy plus y squared. That's also a good looking answer. Let me go to the answer key though and look at it and see if I did a good job in that. Well, I'm seeing the x minus y squared, I'm seeing the x plus y, and I'm seeing x squared plus xy plus y squared. Feel good about that. Let me go to number 7. And number 7, there is no number 7. So I'm going to say that's good. And for the most part, practice those problems. It'll be very similar to the ones you see in the exam. I'm going to switch screens now. All right, let me do that for you. Okay. We just finished number 6, by the way. I can't say this enough times. Problems, when you get the exams, you can be very similar. You should practice these things over and over again to make sure you're familiar with it. So what's the big deal there? The sum and the difference of perfect cubes. What are we doing now? The Sage stuff. So let me go back to the Sage math thing. I'll click on that. It's going to open up a web browser. It's going to launch that URL, which is a sagemath.org URL. When you get to the website, you're certainly more than happy if you want to read through that. I'd love to hear students' ideas when you read through that stuff. And but the bottom line is we're just trying to get your feet wet in coding. So let me click on the CoCalc. Again, I wouldn't recommend for most students at this level to download the software. I would recommend that they use CoCalc instead. Let me click on that. This is a product called Sage. and it's opening up a web-based version of Sage called CoCalc. And so I'm just going to, welcome to CoCalc, click on that. Yes, I want to start a project. I like to start new projects. Notice it's starting up over here. It's getting computer resources from somebody. I want a new project though. I don't want to use any old ones. I want to use a new one. And what do I want to do? They certainly name it. You can feel free to name it anything you want, but I'm just going to simply accept their name and then create a Sage worksheet. That's going to open up a brand new sheet of paper. It's going to look like a Word document. And I'm just going to type in the command. Now, what do I see? Reset. And what reset does, it kind of makes a clean slate, right? So if there's any leftover memory, it'll clear it out. What happens to a lot of students, they hit the return and nothing happens. So want to claim what you do is shift and then return. And then I'm going to say y is a variable. This is typical in computer science. We define a variable. Remember, shift, return. And then want to factor. Now, granted, this is a simple problem. We've actually done this one in class. 8 star y cubed plus 27. We've actually factored that. What is it? That's the sum of perfect cubes. Hit the shift return. And what does it do? It returns the answer back to me. What's the answer? I would have written in a different order. I would have said 2x plus 3 times 4x squared minus 6x plus 9. Let me repeat this. This is a simple problem. You want to learn to do things by hand. Machines can do much more difficult problems. We don't want to feed a machine a simple problem like this. We want to be able to do it by hand. Once you start to master doing things by hand, you're going to start to consider using a computer to do more interesting and difficult problems. All right, thank you.